Now, how many coordinates we have? Well, for two, we have a Cartesian coordinate, right? Or we have a polar coordinate in 2D. Now, for 3D, we have rectangular, right? And we have cylindrical, right? We have spherical coordinate. So more than that, actually, we have more than that. We have, I think we have about 12 of this coordinate. Why they are special? Because see, they are all orthogonal to each other. Orthogonal mean what? Orthogonal mean they are perpendicular to each other. Right, like X, Y, Z, right? X, Y, Z. They all perpendicular to each other. So we use this word orthogonal, right? Now let's say the Cartesian, right? So we draw the coordinate, right? X, Y. Let's say I have a point here. You can call this point a X1, Y1, right? Now then what happened? Then this point will represent a vector. Let's say this vector is A, right? Now, by the way, what is a vector? And what is the vector? So give me some example of vector. Velocity of vector, right?
Yes.
Acceleration is vector, right? And force is vector, right? And electric field vector, right? How you write a vector, right? We put an arrow on the top. And scalar, right? What is scalar? Scalar mean they are only a magnitude, right? Temperature is scalar. And mass is scalar, right? No directions. And pressure is scalar, and so forth. Now here I have a point xy x1 y1, right? So this point will represent by a position vector. So how you draw the vector? You draw it from the origin and then point it to the point of contact. Now in this case, then how are we gonna represent the magnitude and the direction of the vector? And the magnitude of the vector will represent by the length. So how are you gonna find the length? And you use Pythagorean theorem, right? And then how about the direction? The direction will be represented by the angle. So therefore, you can write A, it just like this. Are you with me?
Yes.
Now, about a lot of time, right, we like to use this IJK notation, right? So I can tell you that beforehand. Now, what is the IJK notation? The IJK represent the unit vector along X and Y and Z axis. Okay.
Sir, what's a unit vector? Like, how is a unit vector different than a normal vector?
Now, unit vector mean they have the magnitude of 1. So if I want to represent IJK, Now let's say I'm gonna draw the X, Y, and Z axis, right? X, Y, Z, right? Remember the X, Y, Z is always rotate that way, you know? So if you want to draw them, right? So in other words, if I draw X here, so if I draw X here, here will be Y, here will be Z. You understand what I'm saying? Hello?
Yes.
Yes.
Now I'm just using a conventional way where I'm gonna draw X and Y and Z. Now what is IJK? Well, I will be the tiny vector with a magnitude 1 along the X and tiny vector along the Y and the tiny vector along the K. You got it? Now why this IJK notation is important, right? So in other words, if I have vector like the A, so let's say I have the vector A, the one I had before, and this point here is x1 and y1. What I can do is I can write an A equal to AXI plus AYJ. Then what is AX and AY? AX and AY are nothing more than the coordinate of the point, so which is x1 plus y1j. Are you with me?
Yeah.
Right. So it's much more simpler than the way we draw this way. Now here, the question is, how can I relate X, Y, and Z, right? As you see from the picture, right? You can always write let's say the length is X, right? So I can say the total length is R. So how are you gonna relate all this X1, Y1, R, and theta? So as you see, as you already see that, right? You can write the X1 is equal to R cosine theta, right?
Mm-hmm.
And y1 is going to be r sine theta, right? Or you can write the theta is equal to arctangents of y1 over x1. Good. So what really tell us that? So what really tell us that if I have a x and y and z, right? I have x, y, which is the Cartesian coordinate, right? So we can relate it to the polar coordinate. So polar coordinate mean that you no longer represent the your point by x and y, right? So polar coordinate, you're gonna draw like this. So this point here will represent by x and y, right? But you can also represent it by what? And by r and theta. So what is r? R will be the length from the origin to the point, and theta will be the angle measured from the x-axis to the length, right? Are you with me?
Yes.
Now, what I'm gonna do, I'm gonna give you a simple conceptual question here, right? Okay. So let's just recap what I said. Okay, can you tell me that? Okay, let's do a poll, right? Okay, I cannot do a poll. It's more than one choice, right? Okay, which one is vector?
Acceleration. B,
Velocity
C.
velocity and speed. I mean, yeah.
Okay, acceleration, right? It's
B and
vector.
C.
Velocity, a vector, right? That's it, right? Speed is not a vector, right?
Oh.
So speed is scalar, right? Speed does not tell you the direction. Now then, now we know the vector. The question is how we gonna operate a vector, right? We call it operations of vector. Right? So what type of operation we have, right, for vector? So in general, we have additions and subtraction, right? And also I have the multiplication. By multiplication, we have two types of multiplication. One we call the dot products. Another one we call the cross products. They also have a different name. A dot product also called the inner products. Cross product also called a vector product. Good. Now, then if I want to operate that, right, we can add them out, right? So we have two types of method to find the operation, whether the graphical method, right? So graphical method means we are using the drawing to find the resultant. Or we have an analytical method. Analytical method means we're using the calculation to find the answer. Now, first, I have two vectors, right? Let's say I have A, and then I have B. Now, how are we going to add them? Well, the way we add them is we're using the so-called tip and toes method, right? You put A here. Okay, if you want to mute your, if you want to talk, right, and just reduce your background noise, right, or you can mute your mic. So A here, right? So I'm gonna put from the tips, mean from whatever you start, where you continue to connect them together, like here's B. So therefore, what is A plus B, right? A plus B will be here. Okay, draw better.
This is the graphical method, sir?
Yes, sir. That will be A plus B. A plus B will be what? Which mean the long diagonal, right? Is that right?
Yes.
Yeah. Why I said a long diagonal? Because see, I have a parallelogram, right? So A plus B will be the long diagonal of the parallelogram. A and B will be the size of the parallelogram. Now then, if I have A minus B, right? And you know that in mathematics, right? Or we call the field, right? There's no such thing called subtraction. Subtraction, it means, namely, you add a negative quantity, right? Am I right?
Yes.
Yes. Now, if I draw A and then B, what does B look like? Right? B look like that. Am I right?
Yeah.
Now, I'm gonna draw it other way so I have more space, right? So I'm gonna draw it again. I have A. And then I have B. Now, according to the tip and toe method, right? So you're gonna start from here, and then your resultant will be, here will be represented by what? By the way, this is not B, right? This is minus B, right? So that diagonal line will represent what? A plus negative B, which is A minus B. Now, if you look at them carefully, right? Now, let me erase it. I don't have space. So what I'm telling you here, this one represents A plus negative B, which is equal to A minus B. But if you look at them carefully, what is this line, right? So you can draw it carefully. So that will present a short diagonal, right? Am I right? Hello?
Yes.
So therefore, so if this is A plus B, so the A minus B will be the short diagonal. Good.
Okay.
Now,
okay.
then there's only 2 vector, right? Then I have 3 vector, 4 vector, 5 vector, 6 vector. Then what are we gonna do? No problem, right? We still follow this toe tips method, right? So let's say I have A, I have B, I have C, I have D. So what you're gonna do? So then you're gonna connect them together, right? So this is my B. And then I'm gonna connect the C. Now remember that since 2 vectors same mean they are parallel to each other. And also they have the same magnitude, right? Are you with me?
Yes, sir.
So what is D? That D right here. I'm gonna erase them all. This, we don't need that anymore. Now then what is A plus B plus C plus D, right? The way you draw that is starting from whatever you start, and then you're gonna connect them here, right? So that would present A. Now, one thing is very important is what? The addition, they are non-commutative, right? You know what commutative mean, right?
No.
No.
No, mean the order doesn't matter. So what I'm trying to tell you that A plus B plus C plus D is equal to any order.
Oh.
Okay.
Oh,
Mhm.
see, what did you learn in the mathematics?
Not that.
Did you learn anything?
I learned other stuff.
It's too much problems in math.
Yeah.
Okay, now let me show you that, right? Let's say I'm gonna draw the B first, right? B like this. Now, by the way, I'm using my bare hand to draw that, right? And then you're not gonna expect them, they look exactly the same, right? Here, my D. And then where's my C, right? My C look like this. And then what is my A? My A look like this. Right, am I right? Now, when I add them up together, we're gonna be like this. Now, if you look at these 2 vectors, right, they are approximately the same. Am I right?
Yeah.
All right, so that the order doesn't matter. The order really doesn't matter. Then we call it non-commutative. For the addition, and subtraction, right? Order does not matter. Now,
So
what
that
I'm
means
gonna do, I'm gonna give you a conceptual question right now. Okay. Okay, let me open my question database.
So, sir, that means that you can subtract as well, and it doesn't matter in any order?
Oh, it doesn't matter. Subtract mean you just add a negative vector, right? I did say that before.
Okay.
And just to clarify, non-commutative means that the error does not matter or it does matter.
All the non mean no, right?
So non-commutative means that the order does not matter.
Exactly, right? It just some of my students took they did not take the test. Right? He asked me that whether I can take it again. Well, obviously my answer is no. All right. You understand what I'm saying? Okay, where's my vector? Okay, give me a second, okay? I'm gonna look at it. Okay. So maybe another one. Nope. Okay, let me see. Okay. Okay, let me pause the recording. Now then I'm gonna do one for you, right? Now this one look like P plus Q, right? Am I right?
You start bringing politics into a physics class.
What?
Keep your political opinion to yourself.
What? I cannot. All right. Can you see my PowerPoint? Hello?
Yes.
Yes.
Now I have this question, right? If you have vector B is add to the vector A, which of two of the following choice must be true for the resultant vector equal to 0? You have two choices, right? So that two choice has to be related to the magnitude and the direction.
B and C.
Right, B and C, right, exactly, right? They have to be the same size and they have to be pointing to the opposite direction. You got it? So the answer will be B and C, right? Make sense? All right, now I am going to go back to my whiteboard. Now, let me see. Now, but a lot of time, right, we have this a problem there, 3-dimension. Now, 3-dimension will be a much more complicated, right? Now, let's say I have a mosquito, right? So the mosquito will fly like this. Am I right? So this initial point, I can call the initial position. And the final point here, we call the final position. Am I right? Hello?
Yes.
Now, let's say that they are represented by the Cartesian coordinate. Right? Now, let's say that the initial point, you can draw an initial position here. I'm going to call it R0. Now, let's say this point represents X1, Y1, and C1, right? And then another final position, right? We can represent it by a final position vector, right? We call the R. And here is X2, Y2, and C2. Am I right? Hello?
Yes.
Now, remember that chapter 2, right? We were talking about the displacement, right? Now, what is the displacement here? The way we draw it, the same thing, right? Will be equal to R final position vector minus initial position vector, right? Good. Now, how you represent the displacement vector? The displacement vector, right? we will present by the tip and toes method. Right? So you're gonna draw a vector starting from the initial point. Okay, let me use my ruler. Okay. Right here, right? So I'm gonna use the blue color to draw that. Well, my delta R will be here. Am I right? Hello?
Yes.
Now then, how you gonna represent them? They have field coordinate, right? No problem, right? Remember that I introduced this IJK method, right? So how am I gonna write the R? So the R will be and you're gonna use the coordinate, right? X2I, right? Plus Y2J, right? And then plus C2K, right? Now, a lot of time, the people also write this, no problem. They are equivalents. Good. Now, what is R naught? R naught will be X1I, right? Plus Y1J, right? And then plus C1K. So therefore, what is the displacement vector, right? Then you're gonna subtract them, right? The same term subtract, right? Hello?
Yes.
So that will be a x2 minus x1 I plus y2 minus y1 j plus c2 minus c1 k. Good?
Yes.
Now that's the way we are using an IJK notation, right? Now, very short-handed, very compact, and very concise, right? Very good to represent a vector in 3 dimensions. Now, what I'm gonna do, let me see. Now, I'm gonna give you a, okay, let me see. Okay, I'm gonna give you a problem, right? Now, let me show you this. I'm gonna share the screen so I don't need to copy over. Now, here you go, right? I have a particle, they are under phi consecutive displacement. So R1, R2, R3, right? Find the unit vector notation for the resultant displacement and the magnitude. So what this problem mean, right? This problem mean that you're gonna add this 3 vector together, right? Basically. Are you with me? And then you're gonna find the magnitude, right? I did not tell you the magnitude, right? But the way you find it is same as the 2 dimension. And you can guess. Okay, let's spend a couple minutes on that. Okay. Now, how are we gonna do that? Now, the way we want to add this 3 vector together, right? Hello?
Yes.
So we basically have 15i plus 30j plus 12k plus 23i minus 14j minus 5k plus negative 30i plus 15j, right? So we add them up together, right? So we add them up together. Got it? See, the way we add is I at I, J at J, and then K at K, right? And then when I said I want to find a resultant, mean I want to find a length. So then I'm using a Pythagoras theorem. Did you see my mouse moving?
Yes.
So the X component square, right? And then Y component square, and then C component square. So add that 40. Good. All right, now let me
Can
maybe
you go back, please, Professor?
What?
Can you please go back? I didn't finish copying.
Okay.
Thank you.
We assume that. Okay, let me show you, right? And I think some of them still have the tau. Now, why the square root of phi number, right? Let's say I have a vector in three-dimensional space. Let's say this vector represented by x1. Now let's just call ABC, right? And I want to find a length here. Am I right? Hello?
Yes.
Now then I'm gonna take a projection here, right? Now this length is C, right? Am I right? The height. All right. And what is this length? This length will be A squared plus B squared, right? Am I right?
Yeah.
This one is A, and that is B, right? That's why I said that length is A squared plus B squared. So therefore, what is this length? So you're gonna look at the triangle. I mean, look at this triangle here. So it will be A squared plus B squared plus C squared. Take a square root. All right. So the Pythagoras theorem in three-dimensional space. Are you with me?
Yes.
Yes.
All right. Now, okay, let me see what I'm gonna do. Now I'm gonna give you another example here, right? So let's do this one. Now let's say I have A as 2i plus Vj. And then I have B is 4i minus 5j plus k. And what I'm gonna do, I'm gonna ask you to find A, what does 3b equal to? And then what is A minus B? And then what is B plus 2a? And then what is 1/2 A plus B, right? Good. Now, so far we are talking about the addition, subtraction of the vector, Ijk notation, graphical method, analytical method. Right? Now, what I'm going to do now is the multiplication of vector. Okay, maybe I'm doing one more question here. Okay, let's do one more question here, subtraction. Now, I'm going to draw a coordinate here. Right? Let's say I have three vectors. So A, and then B, and then C. Okay, hello?
Yes.
And C has the angle here, let's say 30 degrees. Now let's keep the value of the A, right? A is 3 unit. So let's say B is same thing, 3 units. And then C is 4 unit. Now, the way I said, I'm saying that, what is A plus 3 plus C, right? So let's say I call R. Now, you have a lot of ways to do it. You can use the IJK notation to do it, right? If you use the IJK notation, you need to recover your pawn, right? Am I right? Now, what is the coordinate for A? So if I use the IJK notation, right, that will be, the coordinate of A will be what? So it will be phi times cosine 45, right? Hello?
Yes.
Yeah.
I said you tell me to stop talking about that. Okay, what is C, right? C will be 4 times cosine negative 30 degree, right? Am I right?
Yes.
So what is this equal to? 45 cosine times 3, right, will be 2.12, right?
2.12.
Okay, how about here? So
Sine.
then I have 30 cosine, right? Positive, right? Negative cosine. And then I multiply by 4, right? Which is 3.46. And then I have 30, right? Negative side, negative side, right? 0.5, right? 0.5 times 4 is -2. Am I right? Hello?
Yes.
Yes. Now, how about B here? The coordinate B very straightforward. Am I right?
Yes. Are you finding those by typing them into the calculator or?
Yeah.
I'm using my brain. I don't use calculator.
Oh man.
Caco brain. La calculadora.
Okay, you got it? Now I know the AX, AY, AB, BX, BY, CX, CY, right? Now you have 2 ways to do that. Now what is RX? Remember that R is like this, RX, nothing more than the AX plus BX plus CX. So what is this? AX is 2.12, right? And BX is -3, right? And then CX is 3.64, right? Hello?
Yes.
Hello?
Yes.
Now then I'm gonna add them up together, right? Then I'm gonna use my brain again. There's 2.58, right?
I use my brain on that one.
Am I right? Then I'm gonna add them out at 2.12 plus 0 minus 2, right? Am I right? Hello?
We're
Yeah.
here, boss. We're here.
0.12.
Now therefore, what is the R? The magnitude of R will be Rx squared plus Ry squared. Take a square root. So it will be 2.58 squared. Am I right?
Yeah.
And then I'm gonna, if you calculate that, they approximately 2.582 because the other magnitude too small. Now, what is the direction? Now, if I want to draw this vector, so I know that X and Y, they are positive, right? So if you add A, B, C together, the resultant vector is gonna lie on here. okay, too small. Not good. Now let me draw again. Will be like this. Right, the length here will be 2.5A, right? Am I right? Hello?
Yo.
Now what is this angle here?
E
2.66.
Y.
That will be RY over RX. Am I right?
Yes.
2.66.
0.12 divided by 2.5A, and then your invert tangent, right?
2.66.
Okay, you is the one tell me to stop talking. Well, you started talking now.
Oh,
You got it? Now, another way to do it, you can use the IJK notation, right? So what is the IJK notation I'm talking about? You can write the A as, right? B is, hello?
Yes.
yes.
And what is C? What is the C value? 3.46. Right. And then what is R equal to? You add them up together. Well, it will be 2.58, right? Hello?
Yes.
Yes.
Will be same thing.
Ooh.
Right? So if you use IJK notation, you don't need to find an angle, right? When you write the IJK notation, you already tell me the direction. Are you with me?
Yes.
Yes.
Now, that will be a very good example to show you the relation between the IJK or the so-called traditional analytical method. Now, what I'm going to do now is I want to introduce the multiplication. Now, I said that before I have two types of multiplication, right? First, it's called a dot product. The way we write a dot product like this. And, or you call it inner product, right? This is just a name of that. And this always give you a scalar. So a dot product always give me a number. And then we have a cross product, right? And cross product, sometimes they call it vector products. And they always give me a vector. Good? Now, first I want to define the dot product first, right? What is a dot product? Now, you have two ways to write it. Now, let's say I have A dot B, right? A dot B is defined the magnitude of A times the magnitude of B, and then multiplied by the angle between them. Good? Now, let's say I have A equal to 4 units. B 4 units at 60 degrees, and B will be a 2 units at 30 degrees. Hello?
Yeah.
Here will be 30 degrees, right? Here will be 60 degrees. So what's A dot B? A dot B with magnitude of A 4 times magnitude of B 2, and cosine. What is the angle between A and B?
30.
30 degrees, right? So if you calculate that, that will be 30 cosine, right, times 8, right? So it will be 6.93. Good. Which is a number. Hello? Yes.
Yes.
Yes, what you're looking for is the angle between the two vectors.
Yes.
Okay. So you subtract them. That's what I did, right?
Yeah. Now, that's one way, right? Now, let's say that if I give you A is in terms of the AX, AY, and AC. right, in terms of Ijk notation. And B will be Bx, By, and Bc, right? Now then in this case, what is the A dot B? Then you have to find an angle between two three-dimensional vector, right? It's gonna be a very difficult, right? So in other words, but here we have another way to write the A dot B. Will be AX BX plus AY BY plus AC BC. You got it? Hello?
Okay.
Now, let's say an example, right? I plus J plus K. B is negative I plus 2J minus K. Then what is A dot B equal to? That will be equal to 1 times minus 1 plus 1 times positive 2, right?
Yes.
And then I have plus 1 times negative 1. Am I right?
Yes.
What is it? 0. So what does really tell us if the two dot product is 0?
Is
Opposites.
They're perpendicular, right? Why they're perpendicular? If the dot product is 0, then mean the angle between them has to be a 90 degree. The only way you get a cosine angle 0 is either they are perpendicular, 90 degree, or they're anti-parallel, right? 90 degree or 270, right? You got it? Are you with me?
Yes, sir.
When you say yes, sir, and then you will involve my political statement again. Okay, now let's say I'm gonna give you two vector here, 2, 2, 2, right? And then I'm gonna give you another vector. Let's say it's minus 1, 1, and minus 3. The question is find the angle between them. Now, this one is more like a calculus problem, right? But how are we gonna do that? No problem. We can use the definition of dot product. Am I right? Hello?
Yes.
Okay.
Now, what is magnitude of A? Pythagorean theorem in three-dimensional space, right? Will be 12 square root. Am I right? Hello?
Okay, yes.
Right? Will be what? 9, 11 square root, right? Hello?
Okay.
Now then, what can I do? What is A dot B here?
The scalar, so
2 times negative 1, right? Plus 2 times 1, right? Plus 2 times negative 3, right? What is this equal to?
-2.
Am I right?
Oh, you add them together. Oh, shit.
-6, yes.
What is other people, you know? They don't never participate. Anyway. Bexy, right? I know you, Bexy. Where are you there?
Yes, Professor.
Oh, you're Bexy. Okay, you're the different Bexy, I know. Okay, Ola, right? What is Ola? Ola,
Que lo que en toque.
Ola,
I had class with you last semester.
Yes, sir.
Ola is the way they in Russian they say hello, you know.
Ya está ahora sin
So you
Spanish,
should
so-
not use that name anyway. All right, now then how can I find the angle? Cosine theta.
Oops, -c.
Am I right? Hello?
Yes.
Yes. Yes.
What is it? A dot B is -6, and then I have square root 11 times square root 12, right? Am I right? So if I'm doing a calculation, right, 11 square root times, and then I'm gonna take a reciprocal on them, and then I multiply by -6, and then I'm gonna take a inverse cosine. Okay, let me do it again. I get 121 degrees. Did you get that? Approximately like this. Good.
Yes.
Now that's one way, and you can use the dot product to find a angle between the two three-dimensional vectors. Now another way about the dot product we call the cosine law. Anyone remember the cosine law? Right, if you have a, let's say I have A, I have B, I have C here, right? And the angle here, theta, right? Am I right?
Mm-hmm.
A triangle, any shape of triangle, right? So the cosine law said that C squared equal to A squared plus B squared minus 2A B cosine theta. Is that right? Hello?
Yes, it is right.
Now, what is A minus B, right? Now, I can represent A and B by a vector. So if you draw something like that, C will be equal to A minus B. Am I right? The short diagonal, right?
Yes.
Now then, I'm gonna write it. What is C squared equal to? C squared is nothing more than C dot C, right? Am I right?
Yes.
Yes, it is.
And then C dot C is equal to what? C dot C is also equal to A minus B dot A minus B. Am I right? Hello?
Yes.
Yes.
Then you, now let me stop the recording.
Professor, it's just hard for us to come up and unmute every time. That's why it takes so long.
Okay, mean your reaction time is very slow.
Yes, because we're taking notes for the other part.
Taking notes and also listening to it at the same
You don't
time.
need to take a note, so I put the video, I put the whiteboard online.
I appreciate that as well.
For us was reviewing.
Okay, now let's do that, right? Now I have A minus B dot A minus B. The way you dot them out is just like the way you multiply them out. A dot A. And then I have negative A dot B. I have a negative B dot A. And then I have positive A B dot B, right? Am I right?
Yes.
Yes.
So there's nothing more than A squared plus B squared minus 2A dot B, right? Remember the dot product is commutated.
Yeah.
It doesn't matter the order. Good?
Good.
Yes.
So therefore, it's equal to A squared plus B squared minus 2AB cosine theta, right? So therefore, you can write a QED, right? Good?
Good.
Now that's the dot product, right?
What's QED? I'm sorry.
QED is a Latin, I mean proved.
Oh, okay.
You don't know Latin?
No, I haven't.
Mean proof.
Awesome.
Or in physics, right? We can even call it a very advanced thing where you will never see that in your life.
What's up?
QED. Don't worry, in Houston area, probably you have a number of people you can count with your finger know this thing, okay? All right, now that will be the dot product, right? Now then I have a cross product, right? What is a cross product? Cross product mean like this. Now cross product give me a vector. And you can write a, now first of all, let's say I want to find the magnitude of cross product. Then what is this? The magnitude of A times magnitude of B times the side theta. But how about the direction? Now the direction is very simple, right? You use the right hand rule. Now let's say I'm gonna draw A like this. I'm gonna draw B like this. So A cos B, right? Then you're gonna swap from the A to the B. And then the direction will be perpendicular to A and perpendicular to B. So what does that mean? So if I draw it, okay, let me draw a better way, okay? So we can draw it. Let's say A here, and then B here. Now cos product, right? A cos B will be perpendicular to A. So what I'm saying is here perpendicular, here will perpendicular. So in other words, if the A, let's say AB is in the XY plane, then A cos B will be in C direction. Do you know what I'm talking about? Hello?
No, I didn't get it.
So does it mean the product's gonna be perpendicular to both the A and B?
Exactly. Let me draw that X and Y and C, right? I'm gonna draw A on XY plane, and then B on XY plane. Now, what is the cos product? A cos B. You have to follow the order, right? You good?
Yes.
You swap from A to B. Okay, I don't want to show you my face, right? But anyway, let's do this. Now, you see my hand right here?
Yes.
Yes.
Then your A, right? You can think about it. Your A will be your index finger, right?
Mm-hmm.
And then your B will be your middle finger, right?
Someday.
And then what is A cos B? You swap from your index finger to the middle finger, right? You swap around. Then your A cos B will be your direction from. Good?
Okay.
No.
Remember A and B
Mm-hmm.
and A cos B, right?
Oh,
It's gonna go up. Okay.
Got it.
Yeah, so
So
you
A.
never forget it if I show you that, right? Good?
Good.
So as you see that A cos B is not equal to B cos A. Why? Now if you have B cos A, what is B cos A? Then you're gonna swap it around that way. So B cos A, the direction of B cos A will be opposite direction. And here will be my B cos A. You understand what I mean?
Yes.
Yes.
So therefore, cos product or the vector product, they are non-commutative. So the order matter. Commutative mean the order does not matter. And non-commutative mean the order matter. I think I make the comment before. Just keep it in mind, right? The order matter. Non-commutative mean the order matter. Commutative mean the order does not matter. Are you with me?
Yeah.
Yes.
Now that's one way to write a cross product, right? Now then, let's say that I'll give you a vector like this. Now I'm gonna use a shorthand notation then.
Wait. No, there's no way I'm playing basketball right now.
You got it, right? Now I have two vector A and B, right? Now then, what is the cross product look like? So that's another way we can write it, right? Then you're gonna use something we call the determinant, right? You know what's a determinant?
Oh.
Determinant, you're gonna write this. And you're gonna order them here, or put them in order. Now, how are you gonna evaluate this determinant? A determinant basically is an array. They have the same row and the same columns. You got it? Obviously, we have another type of linear object where we call the matrices, right? Matrixy, right? Okay, are you with me?
Yes.
Yes.
Now, then how are we going to evaluate the determinant, right? Let's say that I have the I here, right? So what is the component of I? Now, the way you evaluate the component of I, you draw a line here. And then you're going to multiply this, subtract and multiply that. So therefore, I have AY times BC minus AC times BY. Good? Hello?
Yes.
Now then how are we gonna find the J, right? Now remember that we always have this side, plus, minus, plus. So therefore I have a negative sign in front of the J. Then how are you gonna evaluate the J, right? Then you're gonna draw a line here. And then I will have AX. Okay, let me erase this. I'm gonna use the blue color. Then I will have AX times BC minus the AC times BX. Are you with me?
No, I'm kind of there. Okay, can you show me?
All right. And then how can I find the K component or the C component?
AX times BY.
Then I'm gonna draw a line, all right? Draw a line here. And then I will have AX times BY minus the AY times BX. Now, if I write it nicely, right? Now, if you see that for the X component, right, the multiply factor does not involve any X. They all C and Y, right? Hello?
Yeah.
Yes.
Yes. So are these commutative to where the order matters or the order doesn't matter?
No, the order matter.
The order matter here.
When we're cross multiplying, the order matters?
Yes.
Okay.
Now, the one thing I can tell you that, right, if you want to write the B cos A, what is a B cos A? Order matter.
Yeah, I see it now. I'm talking about when we cross multiply in the matrix, like you see for I, it's AY times BZ minus AZ times BY. It can't be AZ BY.
No,
AY.
you get a negative sign. Now you see that, right? So A cos B is not equal to B cos A, right? Because see, I have two rows that exchange. Now, as a matter of fact, I don't know whether you know something called a linear algebra, right? If exchange two rows of a determinant, and then you're going to introduce a negative sign. That's exactly what I mean. A cos B is equal to negative B cos A. Am I right?
Okay.
Hello?
Yes.
That's what I mean. Okay. Now let me see, right? Now this cos product, right, for the unit vector, right, they also follow the order. Yeah, let me show you. Now then the question, what is I cos I? So you're gonna draw a symbol like this. That we call a cyclic notation. Right? Now then I'm gonna draw this. So what I mean is I cos J equal to K, and then J cos K equal to I, and then I have K is called I, right? Equal to J. Am I right? Hello?
Yes. Yeah.
And K, then if you reverse the order, yeah, you will introduce a negative sign. That's what I mean. Always positive. If you reverse the order, I mean you're going this way. Then you introduce a negative sign. All right, make sense?
Yes.
Okay, where's my pen? Okay, my pen head is not good.
For that one, how did you know that I times J is equal to K? How do we figure that out?
Because see, remember that I is in X direction, right? And then J is in Y direction, right? Then you use your hand, right? You swipe around, right hand, you swipe from X to Y. Then your thumb will tell you the direction. Then my thumb will be in the K direction. You always follow this cyclic notation. Yeah? Now let me give you a...
Yep.
Okay. No, I think I was okay. I mean, let's see. Okay. Okay, now I am going to, I'm going to stop here. The reason for that is I have give you a lot of material, right? Okay, let me stop this recording.